Welcome to SEMA.
As you guys know, one of our new products in ERL this year is the new ERL Performance 426 short blocks. Here we are in the WISCO K1 booth. They're one of the guys that we use for the pistons and rods. And I've got Brian Nutter here with WISCO. Let's find out what we're putting in this thing.
All right. When ERL was getting together with us and PowerPorted as well, in terms of figuring out the combinations, that would be good for, the guy that, he's a street strip guy who wants the thing to run for a real long time, on the street. Maybe you run a little nitrous, maybe you run a little blower and everything, but we needed a little bit more cubic inches to get some more grain out of it. That was the deal of just looking at the engine's architecture and saying, we need a piston and the exact right attributes on it that'll do, long-term running. The key to that is the skirt coatings on the parts. You'll notice that every new OE piston that comes out of your Hemi already has skirt coatings on it, and that's key to having a piston that, it has a lifetime of good lubricity and very little wear. It's also very easy on the cylinder wall, so the cylinders don't wear as much as they used to either. The ring packages we're using are thinner, like today's OE ring packages, and that adds horsepower, or actually saves horsepower if you want to look at it that way. Now the only issue with that is you need something that maintains good oil control. These engines do use a little bit of oil from time to time from the factory, and it was basically a matter of juggling ring tensions and the type of ring we use to reduce the oil consumption. What we ended up doing is using some very, very high-end racing technology. It's a nitrided steel top ring. It's very round, very flat. It's got a positive twist on there, so it rides the cylinder wall in an exact certain way. The second ring, although you won't be able to see it with the camera, has a very small hook in the bottom face of that ring, and what that does is do a phenomenal job of scraping oil. Now the thing to using the second ring to do a better job of scraping oil is this oil ring is what is most of the friction within a combination. And so it allows us to reduce the oil ring tension if we use a better second ring. So now we're getting that piston to go up and down the bore with a lot less friction than it used to, and that results in less cylinder wear as well. One of the other key things that you'll see an OE piston do is they'll run an offset wrist pin. And what that does is when the piston is coming up from BDC to TDC, a typical forged piston with an on-center wrist pin has a very abrupt movement up at TDC that makes a piston rattle, and everybody just says forged pistons rattle when they're cold. It doesn't have to be that way if we do an offset wrist pin like the OE does, and then we do a few other things to make the parts a little bit more palatable in terms of the range of compression ratios. We can easily get away with an extra half point of compression, which is worth about 2% of your horsepower and torque all the way from idle all the way up through the RPM range. And then from there, we've got a blower piston as well, which lowers the compression to 9-to-1, and so you can really put a lot of boost to it before you have to worry about the detonation from pump gas.
You mentioned about the extra displacement. What's that going to give you?
Well, what that is with today's computer-controlled cars, if you put a big cam in the thing, the idle isn't so good and everything, and you want something that's streetable. And so the best way to achieve that is with just pure cubic inches. Huge amount of torque right off idle all the way up through the range. Horsepower goes up as well. To that end, we had to look at the architecture within a block and determine how much stroke we could put in this engine, and yet have something that, you didn't have to do a lot of clearancing or material removal. So what we ended up doing and what we've settled upon is a 4080-inch stroke crankshaft. Now this one is built from 4340 micro-polished journals. The oiling is a straight shot oiling system that ensures that the bearings have a constant supply of oil. The connecting rod we use is 4340 alloy as well. There's a lot of, it's an H-beam, and a lot of people are used to seeing the H-beams, but they're not used to seeing one with a lot of the fine features. You'll notice that ours doesn't have the rib in there that acts as a stress riser. The blades are a little bit wider than a lot of typical H-beams. We also use a rod bolt that's very, very high-tech. racing. It is an ARP rod bolt, but it's a proprietary design where we use asymmetrical threads on that. And what that does is, as that bolt is cinching down, it is stretching at the same time. So we've got the thread pitch on it actually designed so every thread holds an identical amount of the load. And so there's just a few other things along with the double bridge cap here, that really keep that connecting rod in line. And we've had these engines well up over 1,000 horsepower. We've run a Hemi engine for 3 weeks with K1 components in it. And when they took the engine apart after running 300 gallons of gas through this engine with boost, everything looked like new. Everything just went right back together again. These things, even when they make a lot of power, they do not have to suffer durability issues at all.
So you're going to have some of this stuff on the shelf, some shelf stock items. Piston-wise, what are your different options that you're going to have available for these guys to run?
Yeah, the whole thing about the Hemis, you have the 5.7, then you've got a 6.1, and for 2009 there's even another cylinder head coming out as well. Basically, we've added 8 new piston combinations for this year that are stroker and non-stroker, high compression and low compression, for a total of 8 different combinations.
Wow. And what are some of the options that you can provide with, all the way from, I know we've got one in our booth right now, it's a 14.5 to 1 compression. What are some of the options you can offer these guys for the pistons?
Right. Well, and that's the fun thing. Right now with these off-the-shelf offerings and everything, you can get it now. Basically, within a couple days, you can have an assembly, basically sent to your shop there where you do the finished machining and you assemble your short block under your guidelines and your quality control. Now, for the guy that wants something a little bit different, maybe he's running race gas, running a bigger cam, who knows what it is, we can totally do, custom configurations as well. That 14.5 to 1 piston is actually this one here. The first company in the market to actually go through and map out the cylinder head and figure out exactly what kind of valve pocket depths we need for the big cams. We've also given, the racer an ability to go with some oversized valve, without crashing into the valve pockets here. So anything from, a blower piston all the way up through a 14.5 to 1 naturally aspirated engine, no problem.